Okay, so let's proceed to your techniques of integration, which is your trigonometric substitution. So, usually the aim of your advanced technique is for you to eliminate your radical in the integrand. So I think the first two advanced techniques, which is your algebraic substitution and your trigonometric substitution, the aim for those techniques is for you to eliminate the radical expression. So what do you mean by radical expression? So these are the square root functions or the root functions or root expressions. So square root, cube root, fourth root, so on and so forth. Okay, so what's different with your trigonometric substitution is that there's a particular format. So as you can see on this left side, so this is the expression in the integrand. And usually what we use as a counterpart for these expressions is we're going to let our terms be in theta. So notice that we have theta in the terms that we need to substitute as your u parameter. So not totally u, but later on we'll discover that all our expressions will be converted into trigonometric functions. So sine theta, cosine theta, so on and so forth. So what's the difference between your algebraic substitution and your trigonometric substitution is that, for example, since you have your inverse trigonometric functions before, so let's say you have the integral of du all over square root of a squared minus u squared. So as you can see, it's the same format as the first formula, right? And then the corresponding integral for this one is arc sine u over a plus c. So notice the corresponding trigonometric substitution being used is u is equal to a sine theta. So most likely if you cannot achieve the format of your inverse trigonometric functions and you have this term in your expression or in your integrand, so we're going to use trigonometric substitution. So we'll get to that later, why we cannot achieve the inverse trigonometric integrals. So for example, in the second expression, so you have a squared plus u squared. So again, from the inverse trigonometric functions, our formula is a squared plus u squared, which is 1 over a arc tangent u over a plus c in the formula. So notice that we also have tangent theta as your trigonometric substitution in this expression. So we have a squared plus u squared, but the expression is a bit different. It only has a square root in the a squared plus u squared expression. Okay. Then lastly is, I think the last trig function is your u square root of u squared minus a squared. So notice that the square root of u squared minus a squared is present. Okay, and then the particular answer for this one in your inverse trigonometric functions is 1 over a arc secant u over a plus c. So notice also that our corresponding trigonometric substitution is in terms of the second function also. So again, if you cannot achieve the inverse trigonometric format, so what we do is we go to the advanced technique, which is your trigonometric substitution. Alright, so try to remember the different trigonometric substitution formulas with their corresponding format in the expression of the integrand. Okay, so muna siya, mga partner na siya, di ba? Okay, so for you to appreciate the technique, so let's go to the example. So we're going to discuss 6 examples. Okay, so let's start with number 1. So we have the integral of 1 over x squared times the square root of 16 minus x squared. So as you can see, so again, if you try to follow the inverse trigonometric formula, so let's write it first in red. So again, the format, so as you can see, this one is a squared minus u squared. So notice that in the trigonometric formula, inverse trigonometric formula, you have du all over a squared minus u squared, which leads us to an answer of arc sine u over a plus c. So if you try to look at the expression or in the integrand, so this one is following the format, diba? So you can say that it follows the format closely, diba? But notice that we have x squared in the expression. So maraglisod siya achieve, diba? So since we cannot follow the format in your inverse trig function, so that's the time that we're going to use the advanced technique, which is the trigonometric substitution. So let's try to erase first. Okay, so what we normally do is, this technique is we try to observe first the radical expression. We try to observe the format. So as you can see, since it's constant minus the variable squared, so the format is a squared minus u squared. And again, the corresponding formula for this one, the corresponding trigonometric substitution for this format is u is equal to a sine theta. Alright? So next step is we need to follow the format first, or identify the parameters of the format. So starting with a squared first. So that's 16. And then our u squared is x squared. Then getting the square root, since we need the values of your u and your a parameter for the formula. So this formula here. So getting the square root of both sides, so you have a is equal to 4, and then you have your u is equal to the x parameter. So next is we utilize the formula. So utilizing this formula here, so you have x is equal to 4 sine theta. So again, our objective here is to eliminate the radical expression, but another objective is for us to translate the whole expression into terms of trigo functions. So sine theta, cosine theta, so on and so forth. So we don't derive here in your u like we normally do, diba? So getting u, then getting the du immediately, diba? But this time is we're going to utilize this formula. So mag-agad ta sa formula na. Okay, so di na ta dire. We won't be utilizing u anymore. So the purpose of identifying your u and your a parameters is for us to just use the formula, so we can identify the values for your u and your a. So after identifying the value of the formula, so next step is we try to get the derivative. So derivative of x is dx. Then derivative of 4 sine theta is 4 cosine theta d theta. Alright, so once you got the x and the dx, so notice that we can replace dx with 4 cosine theta. Your x squared is, of course, we can replace the x part because the squared part can be included in the transformation later. So again, this one, the x here is going to this direction, and then the dx is in this direction also. So what's left for us to substitute is your square root expression, which is your square root of 16 minus x squared. So how do we eliminate your square root of 16 minus x squared? Is that, of course, we're going to utilize the formula again. So notice that it's a sine function. So again, your sine, cosine, and tangent function all came from the right triangle. So being derived from the right triangle. So let's draw a right triangle first. So again, if we try to utilize this formula, which is in this aspect. So again, if we try to isolate this one, or we try to isolate the sine function, so this becomes sine theta is equal to x all over 4. So again, as per definition of the sine function, that's the opposite side of the angle all over the hypotenuse. So let's say this one is our angle theta. So the opposite side is your x, opposite of the angle. Then your hypotenuse is your 4. Okay, so getting the third side, so by Pythagorean theorem, so Pythagorean theorem, that's c squared is equal to a squared plus b squared. So let's say this one side is unknown, so obviously it becomes, so let's say this one is a, so we have a is equal to square root of c squared minus b squared. So that's the square of the hypotenuse minus the square of one leg. So this becomes 4 squared, so that's 16, minus x squared. So notice that it's the same as the square root function above. Diba? So this time is once we have established our right triangle and identified the different parts through the formula earlier, which is the sine function, and we try to obtain the value of the unknown side through Pythagorean theorem. So the next step is for us to pair the radical expression with a constant. So let's circle first the radical expression, then we circle the constant in the right triangle. So after determining the radical expression and the constant, so we're going to identify which particular trigonometric function we're going to use for us to pair up the radical expression and the constant term. So as you can see, if we're going to observe the angle theta, so most likely we're going to use the cosine function. So cosine theta is equal to adjacent side, so adjacent of the angle all over the hypotenuse. So this will be square root of 16 minus x squared all over 4. So for us to eliminate the radical expression, so we're going to isolate the radical expression on the right side. So this becomes 4 cosine theta is equal to the square root of 16 minus x squared. So notice that this one is going here. So as you can see, we can now replace every term in your equation. So let's go back to the red. Okay, so starting first with dx. So again, this one is our dx. So that will be 4 cosine theta d theta all over, so that's x squared. So notice that our value for x is 4 sine theta. So this will be 4 sine theta squared. The next is your square root of 16 minus x squared. So this one is this value here, which is 4 cosine theta. All right. So next is, of course, we try to simplify it first before before integrating the rest of the equation. So canceling out 4 cosine theta. So what is left is the integral of d theta. So all over, so this will be 16. So 4 squared is 16. And then sine squared is sine squared theta. Alright, so if we try to simplify further, so let's get the constant outside the equation. So that will be 1 over 16. And your 1 over sine squared theta can be represented as cosecant. So cosecant squared theta d theta. So notice that in this formula, it's already a basic trigonometric formula which we can integrate immediately. So that will be 1 over 16 times the integral of cosecant squared theta d theta, which is negative cotangent theta plus c. So we have negative 1 over 16 cotangent theta plus c. So this is not yet the final answer since we need to bring back the value of your cotangent. So how do we do that is, again, we go back to the right triangle we have created earlier. And we determine the cotangent function. So again, as per definition, so let's write it here. Cotangent theta is equivalent to the adjacent side all over the opposite side. Okay, so notice that the adjacent side of the angle is this one, the square root function, and then the opposite side is the x value. So that will be square root of 16 minus x squared all over x. So the final answer is negative 1 over 16. So times square root of 16 minus x squared all over x plus c. So the final answer is negative square root of 16 minus x squared all over 16x plus c. So this is the final answer. Okay, so do you have questions for the first example?
Sir, question, sir.
Mm.
Kani ganing sa pagpili mo sa data dito sa rectangle, sir.
Mm.
Saan mo po yun, sir, natin sir?
So actually, you can just choose anywhere sa right triangle. So for example, dili ko, di ba? So it won't matter kung asan ninyo ibutang ang theta. So let's say I'm going to put theta here above, di ba? So as long as you follow this one, the formula, so the opposite of the angle is x, di ba? This one is 4. So notice that it's a different orientation compared with this one. So ako nang gi-follow ang format sa one. Sa gasa nyo ibutang ang theta, so as long as you follow the definition of the trigonometric function, so safe ra gyapon mo sa inyong answer. So let's say ganina, di ba? So this one theta here. So the opposite of the angle is x. The hypotenuse is 4. But opposite over the hypotenuse. Opposite over the hypotenuse. So dili siya ma-matter kung asa niyo ibutang because the other side will always be 16 minus x squared, di ba? 16 minus x squared.
Okay, sir. Thank you, sir.
So, muna dyan yung timanan. Basta as long as you have clearly defined your trigonometric functions, so di na siya matter kung asa yung butang angle as long as you follow the definition. So, always take note that the hypotenuse is always opposite the right angle. Diba? Right angle here. The opposite of the right angle is the hypotenuse. So, same goes here, diba? So, maski na ako pa na siya drawing on the other orientation, let's say on orientation, then let's say this one is my theta. So, this is my hypotenuse, diba? So, opposite side is x, this one is 4. So, let's say this one is my theta. So, this one is, x value, this one is 4. Diba? So, opposite side all over the hypotenuse. Opposite of the angle all over the hypotenuse. So, muna siya. Okay, so have I answered your question?
Yes, sir. Nag-gets po, sir.
Okay, sige. So, any more questions before we proceed to the next example? So, pangutaan na mo kay lisod ra baron mangutaan na kay kuan. Mas maayo mangutaan na ron kay okay tas yung mga naon, di ba? Compared sa face to face na makita ay jud. Okay, so I think there's no question. So before we proceed to the next example, so notice that everything in blue is the process of the trigonometric substitution, and then the red part is the process of the integration. So once we have achieved the certain degree of substitution, so the next step is for us to integrate. So kaning red part is all integration. The blue part is the process of the trigonometric substitution. Okay, so let's proceed to the next example. So next is we have the integral of 1 over x times the square root of 9 plus x squared. So again, if we try to, so looking at the expression, so we cannot use the inverse trigo function since our format for that one is du all over a squared plus u squared. So notice that if you compare it with the given expression, so it's very far from the format of the inverse trig function. Okay, so muna di siya magamit, diba? So let's try to erase first. So we proceed to the higher technique, which is your trigonometric substitution. So again, observe first the radical expression and identify the format. So looking at the expression, so the format is constant first plus the variable, so that will be a squared plus u squared. So again, the formula for this one is u is equal to a tangent theta. Okay, alright, so next step is for us to identify the values of your a and your u parameter because we need that one for the formula later. So a squared first is 9 and then a is equal to 3. So next is u squared, which is the x squared. Then next is your u parameter is equal to x. So upon determining your values for a and u, so we now utilize the formula. So the formula is u equals a tangent theta, so that will be x is equal to 3 tangent theta. Okay, so next step is for us to determine the derivative of this one. So dx, so derivative of tangent is secant squared theta, diba? So 3 secant squared theta d theta. So notice that we can now replace dx with the corresponding value and also the x. So also notice that what we are trying to replace are all terms, are all expressions of your trigonometric functions. So tangent theta, secant squared theta. Okay, so what's left for us to determine is the substitute value for your 9 plus x squared. So again, before we write the right triangle, so let's isolate first the trigonometric function. So that will be tangent theta is equal to x all over 3. So again, as per definition, tangent is opposite of the angle all over the adjacent of the angle. So opposite all over the adjacent side. Okay, so let's say we're going to create a different triangle, di ba? So sa inyo hang para masabtan sa ninyo na. So let's say I'm going to write the angle here, di ba? So opposite of the angle, di ba? Opposite, atbang niya, atbang, sabi sa niya pa atbang. So that will be the x parameter. Adjacent of the angle is, so of course, ang adjacent side is always the side not opposite the 90-degree angle. Kaya ang opposite the 90-degree angle is the hypotenuse. So 3. So again, as per Pythagorean Theorem, so the Pythagorean states that the hypotenuse is the square root of the, the square of the sum of the square of the sides, di ba? So meaning na may mo siyang square root of 9 plus x squared. So after determining the hypotenuse or the different parts of the right triangle, so again, pair your radical expression with a constant term. And the next is we identify a particular trigonometric function for this pair up. So looking at your angle, that will be adjacent side all over the hypotenuse. So this one is cosine function. So cosine theta is equal to 3 all over the square root of 9 plus x squared. So isolating your square root function, so this becomes 9 plus x squared is equal to 3 all over cosine theta. So 1 over cosine, so we can represent it as 3 secant theta. Okay, so this one is this term here. So for those of you who don't want this particular triangle, so drawing again a right triangle. So this one is theta. So opposite angle is x, adjacent side is 3, hypotenuse is 9 plus x squared. So still the same, di ba? So pair up is cosine gyapon. Adjacent side all over the hypotenuse. Okay, so next is we substitute the different values. So the square root of, so first is dx. So that will be 3 secant squared theta d theta. So secant, secant, na depende sa inyong pronunciation. So next is your x parameter. So that will be 3 tangent theta. 3 tangent theta. And then lastly, your square root of 9 plus x squared, which is this one. So this will be times 3 secant theta. So cancelling out 1 theta and 3 also. 3 and then secant. So what's left is secant theta d theta all over 3 tangent theta sa denominator. Okay, so let's try to simplify even further. So if you're not sure if napapag-cancel sa inyong trig function, so let's try to make it even more simpler. So secant theta is 1 all over cosine theta, and then tangent theta is sine theta all over cosine theta. So this one is d theta in the numerator. So notice that we can cancel out the cosine theta. So if you're wondering ano makancel siya, so if we try to make it in a division manner, so divided by sine theta all over cosine theta, so getting the reciprocal of the second term, then multiply na, di ba? So cosine theta all over sine theta. So cancel, what's left is 1 all over sine theta. So kanya ko ay shortcut lang na siya kay, of course, dapat shortcut na ta dapat ani nga panahon, di ba? Kay we have mastered it from high school and also from senior high. So sharo di pa jud makakibaw og simplify, di ba? So 1 all over sine theta d theta. So this is 1/3. So again, we can represent your sine theta with cosecant theta d theta. And the corresponding answer for this one is 1/3. So that's ln. So again, if you try to remember your formula, so this will be the ln. So ln of cosecant theta minus, so minus ba tong, let's see if minus pa siya or plus. So cotangent theta plus c. Alright. So since this is not yet the final answer, so again we go back to the right triangle and identify the cosecant function and the cotangent function. So looking at your, so let's try to erase lang one triangle. So if we try to determine cosecant theta, so again that's hypotenuse all over the opposite side. So that will be the square root of 9 plus x squared all over x, right? So hypotenuse all over the opposite side of the angle. So cotangent theta is adjacent side all over the hypotenuse. So adjacent side all over the hypotenuse. So that will be 3 all over x. So this will be 1/3 ln of, so cosecant theta is square root of 9 plus x squared all over x. Then cotangent theta is 3 all over x plus c. So we can simplify it in one term because the denominator are similar terms. So we have the same denominator, so we can combine them. So this will be square root of 9 plus x squared minus 3 all over x plus c. So this is your final answer. Alright, so do you have questions for this example? So nag-gets ra ninyo, nag-gets ra? Okay, so I think nag-gets naman siguro. So again, the blue part is the process of the trigonometric substitution, and the red part is more on the integration process. So just try to answer this one again and follow the recording para mag-guide mo. Okay, so let's go to example number 3. So as you can see, so it's really far from the inverse trig format because the square root is in the numerator. So if in this manner, so as you can see, the format is u squared minus a squared by observing the square root expression. So the format is u squared minus a squared. So again, the formula for this one is u is equal to a secant theta. So identifying the different parts, so u squared is x squared, u then is equal to the x variable, a squared is equal to 25, and then getting the square root, so a is equal to 5. So getting the values for your u and a and apply it in the formula, so you have x is equal to 5 secant theta. So again, after identifying the formula is we get the derivative. So di ba procedural na kayo ang so it's a step by step process in the trigonometric substitution. So next is dx, then 5, then the derivative of your secant theta is sectan, di ba, sec theta tangent theta d theta. Right, so next step is before we apply the right triangle or create the right triangle, so we isolate first the trigonometric expression in the formula. So this one becomes secant theta is equal to x all over 5. So again, as per definition of your secant theta or secant function, that will be hypotenuse all over the adjacent side of the angle. So drawing the right triangle. So ana lang pag-draw para namoy universal nga right triangle. So theta. So again, as per definition, hypotenuse all over the adjacent side. So hypotenuse is x, adjacent side is 5. So getting the unknown side, which is this one, so that will be the hypotenuse minus 1 leg, diba, which is 25. So next step is for us to pair this one up with a constant. So why do we need to pair this one with constant? So again, if you try to compare later on your notes, so if you try to compare, if you try to pair this one up with the variable, so most likely magbalik-balik si x, di ba? Yan, di man ta ganahan mabalik si x, di ba? Kaya ganahan ta mo move on, di ba ta? Joke lang. Na. So again, if you try to pair this one with the x function, so most likely, kung tanawin ninyo, sine theta is equal to x squared minus 25 all over x. So notice that if we try to isolate the radical expression, so instead of getting purely trigonometric functions in your substitution, so nagay po yung x nga parameter, di ba? Nya ato man na siyang i-try o eliminate ang mga variables nga x, di ba? So muna, it's best to pair them with a constant because ang constant pwede rin siya ma-neglect in the integration process later. So atong i-try sa da o compare. So if you look at the expression, so this one is tangent. tangent theta. So opposite side of the angle, that's x squared minus 25 all over 5. And then isolating the radical expression, so you have 5 tangent theta is equal to x squared minus 25. So again, if you compare this one side by side, so notice that the left side is 5 tangent theta, which is, I think, safe for us to replace or substitute since it's a constant plus the trigonometric function. Comparing it with this one, nga mabalik ang x, di ba? Banya, if you look at the formula, I mean the expression in the equation given, so we replaced x with 5 secant theta, di ba? Yaman, mabalik po dyan sa x3 niya, replace na po ka balik og 5 secant theta. So, madoble ang trabaho, di ba? So, mana, we try to replace it with one go nga. So, upon achieving the particular term or expression, so automatically we eliminate the variable in the given equation. Diba? So the x parameter is we replace with 5 secant theta, so there's no more x in the denominator. Now, if you try to replace it with x sine theta, so mabalik ang x sa numerator, di ba? So mabalik na sa mo substitute sa x parameter. So warag kuan siya ba, wali ka humana nga substitution, di ba? So yun na ma-discover once you try solving it on your own. So basta mo na siya ang rule. So ako na siyang made simple nga. Inigahayo mo sa right triangle. Once you finish creating the right triangle, so always pair them up with the constant. So muna sila always ang pair. Then get the trigonometric function. So the square root of x squared plus 25 is 5 tangent theta. And then your dx is 5 secant theta tangent theta d theta. So we're done with the trigonometric substitution part. So let's go to the integration process. So starting off with the square root of x squared minus 25. So this is 5 tangent theta. So all over the x value. So x parameter is 5 secant theta. So 5 secant theta. And lastly is your dx, which is this term here. So this is 5 secant theta tangent theta d theta. So eliminating, so we now have 5 secant theta. So cancel out 5 secant theta. So what's left is 5. So integral of 5 tangent squared theta d theta. So if you try to observe the remaining expression, so this can be solved using type B, di ba? So again, if you've forgotten what type B is, so that is the cosecant, the secant and tangent pair up. So since tangent is squared, and that what remains of your tangent expression, your equation. So let's try to isolate first. So again, if you forgot the rule, so just try to recall it later. So this becomes secant squared theta minus 1 d theta. So again, we can now integrate because we have a formula for secant squared, integral of secant squared, di ba? So the first term is 5. So again, the integral of secant squared is tangent. So tangent theta. Then minus, so integral of 1 with respect to d theta times 5 is 5 theta plus c. Alright. So of course, we go back to the triangle. So tangent theta. So again, that's opposite all over the adjacent side. So tangent theta is square root of x squared minus 25 all over 5. So we can now replace your tangent with this expression. So how about the theta? So where do we get theta? So your theta is we get your theta since we don't know the particular trig function for your theta and theta lang ibutang. So the safe method for us to do is we go back to the formula, which is this one. Then since it's already converted, so what we do next is we just get the inverse function for this one. Diba? Kanang atong button sa calculator to get the angle. So arc secant x all over 5. So this one is this value here. So the final answer will be the square root of, so let's try to view all the expressions. So this will be 5 times the square root of x squared minus 25 all over 5, then minus 5, then replace it with the arc secant x over 5 plus c. So we can still simplify this one by cancelling out 5. So again, you cannot cancel the 5 here because the over 5 in this term is in the trig expression. So dili siya algebra to algebra, but it's algebra to trigo. Okay, so the final answer is the square root of x squared minus 25 minus 5 arc secant x over 5 plus c. Alright, so that's the final answer. So do you have questions or clarifications? So I think mura na yung button, pabalik-balik na siya. So first is you do first the trig sub process, then next is you do the integration process. So murag maka-complicate lang siya later, especially in your problem set since you'll be dealing with different because for example later on in your problem set your u squared and your a squared could be any other expression aside from algebraic expression. So let's say your u squared is equal to e to the power of 2x, diba na? So pwede siya may nana. Then your u is equal to e to the power of x, and it could be, diba? Then a, let's say, is 9, then a is 3, diba na? So pwede siya ana. Or it could be that your u squared could be a trig function already, so it could be sine squared theta. Then u is sine theta, ana. It could be, diba? So muna, usually the hardest part is in the integration process now because the trigonometric substitution part is more procedural, diba? So kaning blue part is more procedural because you have procedures for this one leading up to the other expression. Now next is kato na sa integration process, which is I think a bit challenging depending on the given expression. Okay, so Chica aside, so let's go to the next example. Okay, so as what I have mentioned earlier, so your your u squared could be different values, so it's not always that it's a perfect square or unsa. So notice also that it's u squared plus a squared, but our format is a squared plus u squared. So always remember if in addition, so you can interchange the two terms. That's commutative property of addition. So this will be in the format of a squared plus u squared. So again, the formula for this one is u is equal to a tangent theta. So starting off with a squared first, so that will be 9. Then a is 3. Then your u squared is 4x squared. So the u parameter is 2x. So using the formula, so we're going to have 2x is equal to 3 tangent theta. Alright? So notice that since we're going to replace x in the term above, the equation above, so we need to isolate x on the left side. So this becomes x is equal to 3 halves tangent theta. So we can now replace the x value. So next is getting the dx. So dx is 3 halves. So the derivative of tangent is secant squared theta d theta. So we can now replace dx. So what's left for us to replace is the square root of 4x squared plus 9. So again, coming from the formula, so let's try to isolate the tangent expression. So tangent theta is equal to 2x all over 3. So again, as per definition, tangent is opposite the angle theta, adjacent of the angle theta. So writing the right triangle, so let's say this one is theta. So opposite the angle, that's 2x. And then adjacent side is 3. So getting the hypotenuse, so obviously the square of the two sides, so that will be 4x squared plus 9. So next step is for you to pair the radical expression with a constant. Okay, so this expression is cosine function, diba? Okay, that's the adjacent side of theta all over the hypotenuse. So we have cosine theta is equal to 3 all over the square root of 4x squared plus 9. So this becomes the square root of 4x squared plus 9 is equal to 3 all over cosine theta. So which can be also represented by 3 secant theta. So this term here can be replaced by 3 secant theta. Alright. So since we are done identifying the particular terms for the substitution process, so we can now proceed with the integration process. So starting first with dx, that's 3 halves secant squared theta d theta. So next is the denominator. So that will be 3 halves tangent theta. Then multiplied by the radical expression, which is this term here, 3 secant theta. 3 secant theta. So cancelling out 3 halves, cancelling out 1 secant. So what's left is the integral of secant theta d theta all over 3 tangent theta. So I think this one is the same as the earlier example. So 1/3, then getting it in the basic term so that we can see if we can still cancel out something. So as you can see, we can cancel out sine theta. So that will be 1/3 integral of 1 all over sine theta d theta, which is 1/3 integral of cosecant theta d theta. So again, the integral for cosecant theta is 1/3 times ln of cosecant theta minus cotangent theta plus c. So before getting the final answer, so again we go back to the right triangle and identify the cosecant and cotangent terms. So cosecant is hypotenuse all over the opposite side. So that's 2x. Then cotangent, that will be adjacent all over the opposite side. So that will be 3 all over 2x. So final answer is 1/3 ln of square root of 4x squared plus 9 all over 2x minus 3 all over 2x plus c. So the final answer, since you can combine the two terms, is ln square root of 4x squared plus 9 minus 3 all over 2x plus c. So this is the final answer. Okay, so do you have questions or clarifications? So magbalik-balik na board na siguro mo. Okay, so let's proceed to the next so that we can finish earlier. Okay, so looking at the format, so that's u squared minus a squared. So the formula is u is equal to a secant theta. Okay, so next is we're going to identify u, which is u squared, which is x squared. So u value is x, and then a squared is 4, and then a is 2. So using the formula, we have x is equal to 2 secant theta. So again, getting the derivative, 2 secant theta tangent theta d theta. Okay, so this one is the dx, this one is x term. So we can replace this one. So next is we isolate the secant function from the formula. So this is x all over 2. So again, secant function is defined as hypotenuse all over the adjacent side. So creating the right triangle. So hypotenuse is x, adjacent side is 2. So the other side is obviously x squared minus 4 by Pythagorean Theorem. So next is pairing up your square root with a constant. So looking at the two terms, so we're going to utilize tangent function. So tangent is opposite all over the adjacent side. So this becomes 2 tangent theta is equal to the square root of x squared minus 4. So we can now replace this one with 2 tangent theta. So pabalik-balik na, maragpaspas na kita kay balik-balik naman siya. So starting off with dx, so that's 2 secant theta tangent theta d theta. So x squared, so that will be 2 secant theta squared. Lastly is the other term, the square root function, so 2 tangent theta. So cancel out 2, cancel out 2, cancel out tangent, tangent, and cancel out 1 second. So the remaining term is d theta. Then applying the square, which is, since we canceled out 1 second already, so we have 1 second theta. So 4 second theta, I mean. Then this one becomes um, cosine theta d theta all over 4. Or in simpler terms, that's 1/4 integral of cosine theta d theta. So the integral of cosine, so that's super basic. So that's 1/4 sine theta plus c. So again, look, going back to the right triangle, so sine theta is the square root of x squared minus 4 all over x. That's opposite all over the hypotenuse. So we have 1/4 times the square root of x squared minus 4 all over x plus c. So the final answer is square root of x squared minus 4 all over 4x plus c. Alright, so questions? Okay, going once, going twice. Okay, let's proceed. So this will be the last example. So basta nabuhayan na mo diya kay last example na. So before we try to get the trig sub for this one, so since this one is 3 halves, so let's try to simplify this one first. So this will be the integral of dx. So in terms of its radical expression, so notice that the denominator is 2. So that will be the square root of x squared plus 1 and then cube, di ba? So simplifying it further, so we can still get one term outside the radical expression. So this becomes dx all over the, so that will be taking 1 x squared plus 1 in the equation, then square root of x squared plus 1, diba? I think that's the correct term. So by this time, we can now identify the particular trig sub we're going to use. So looking at the expression, so this is in the format of a squared plus u squared. So we're going to use tangent function. So u is equal to a tangent theta. So u squared is equal to x squared. U is equal to x. Then a squared is 1. So a is equal to 1. So by formula, this will be x equals tangent theta. Diba? So derivative is secant squared theta, d theta. So we can replace dx with secant squared theta. So your x squared plus 1, so your x can be replaced by tangent theta. So the 1 later on, the plus 1, so we can deal with that later once we are done replacing the variables of x. So next is we try to create a right triangle again. So isolating tangent function. So this will be tangent x over 1, diba? So again, opposite side all over the adjacent side of the angle. So right triangle, so we have theta here, opposite is x, adjacent side is 1. So this is x squared plus 1. So next step is for us to pair this one with the constant. So looking at the the terms being paired, so we can use cosine function. So cosine theta is equal to adjacent side all over the hypotenuse. So isolating the radical expression, so we have 1 all over cosine theta, which can be represented as secant theta. So we can now replace this one with this term here. Okay, so since we are done identifying the different terms, so we can now replace them or substitute them. So starting with dx, so dx is secant squared theta d theta. So all over. So next is x squared. So this will be tangent squared theta plus 1. Then times, so sunod. So sunod is secant theta. So this term here. Okay, so canceling. So before we cancel out, so notice that this term here is a Pythagorean identity. So instead of representing this one with tangent squared theta plus 1, so we can represent it as secant squared. So this becomes secant squared theta d theta all over secant squared theta secant squared theta. So what's left is the integral of d theta all over secant theta. So 1 over secant is, if you do the math, the division part, this becomes cosine theta d theta, which leads us to its integral, which is sine theta plus c. So sine theta plus c. Then looking at the triangle again, so sine function is x all over the square root of x squared plus 1 plus c. So since we don't want any radical expression in the denominator, so we're going to use rationalization. So the final answer is now x times the square root of x squared plus 1 all over x squared plus 1 plus c. So this is the final answer. Okay, so do you have questions or clarifications? Okay, so if you don't have questions, so I think that's it for today. So see you all on Thursday for the next topic.